It's true. Okay, well, it is 7 p.m., so let's get started. Good evening, everybody. I am Flagstaff Festival of Science Board member Sherry Schaefer, and welcome to the live stream of the impact of pandemics on human history. Before we begin, I'd like to thank our festival sponsors, especially our Supernova friends. That's the Alfred P. Sloan Foundation, the Arizona Community Foundation of Flagstaff, Northern Arizona University, Flagstaff Arts Council, the City of Flagstaff, the Better Business Bureau, and W.L. Gore and Associates. If you have any questions during the presentation, please put them in the submit questions box provided on the website, and we'll get to as many as we can at the end of the presentation. Also, please be sure to provide any feedback on this or any of the other programs using the QR code or the button near the top of the SciFest 2020 page. And now I'd like to introduce Dr. Frank von Hippel. He's professor of ecotoxicology at Northern Arizona University, and he's author of a brand new book published this month by the University of Chicago Press. It's called The Chemical Age: How Chemists Fought Famine and Disease, Killed Millions, and Changed Our Relationship with the Earth. I'm pretty excited about this. Thank you very much for joining us, and please take it away.
Thanks, Sherry. Appreciate it. And thanks to the Festival of Science for having me. This is the second year in a row that I'm doing an event with the festival, and it's a lot of fun, so I appreciate it. And I will pull up my presentation now, so you hopefully can see it.
Yes, we're good.
Okay, great. So today I want to talk just a little bit about the impacts of pandemics on human history by discussing really one case study, the case study of malaria, but also just briefly touching on three others: bubonic plague, yellow fever, and typhus. And we'll do all this probably in about 20 minutes to leave time for questions and discussion afterwards. And of course, we could talk about the current pandemic that we're in now, which is the worst that we've faced in a century. So this is part of the book that Sherry just mentioned, The Chemical Age, which was just published this month by the University of Chicago Press. And part of this book deals with the history of pandemics and how chemists developed chemical tools, that is pesticides, to kill the vectors of diseases. So what I want to do is talk about the example of malaria. Malaria is actually the oldest epidemic/pandemic level disease that humanity has faced, because it began to be a serious problem with the advent of agriculture about 10,000 years ago. When humans began growing crops, of course, they had to do this around a water source, and that meant that there was a ready supply of stagnant water for breeding mosquitoes, for Anopheles mosquitoes, and blood meals in the people that lived around them. So ever since then, ever since agriculture arose about 10,000 years ago, malaria has been the #1 killer of people. We've known about malaria for quite a long time. On the right, you can see the Hippocratic Oath, one of the original versions. And on the left, you can see a Chinese medicinal text describing malaria from about 2,500 years ago. So this is a disease that's been known about for a long time, but really very poorly understood. And that is, it's very difficult to differentiate malaria from other febrile or fever-inducing illnesses. But quite a long time ago, people started noticing an association between malaria and wetlands or bogs or any kind of stagnant water area. So for example, in Shakespeare's The Tempest, Shakespeare wrote, "All the infections that the sun sucks up from bogs, fens, flats on Prosper fall and make him by inchmeal a disease." And this was referring to malaria. The name itself, malaria, comes from the Italian word mala aria, which means bad air. So what people thought is that you got malaria from bad air associated with marshes. And as a result, even some ancient people in places like Baghdad would drain wetlands in order to get rid of malaria. Malaria had a major impact on human history in many ways, and one of those has to do with the slave trade. So when the slavers arrived on the Africa coast and started capturing and transporting slaves to the New World, they found that the slaves from Africa were resistant to malaria, naturally resistant to malaria. And the reason for that was that Endemic malaria, the 4 deadly varieties of malaria, really is centered in tropical Africa. And there's a mutation that arose in tropical Africa for the sickle cell gene that provides protection from malaria. So if an individual is heterozygote for that gene, they have one of the mutated alleles, the small s allele, and they have a normal allele. They still have normal oxygen carrying capacity, but they have malaria resistance. And this, unfortunately, was part of the reason for the downfall of Africans into slavery. When the Europeans colonized the Americas, they enslaved Native Americans, but Native Americans were dying in huge numbers from infectious diseases that the Europeans and the Africans brought with them, including malaria and yellow fever, typhus, and influenza. And they also had indentured servants that they brought over from Europe, but these people too were dying from malaria and yellow fever. But African slaves had genetic resistance to malaria, and they had acquired resistance to yellow fever, since most of them would get it as children when it's more benign. And so this really led to the entrenchment of slavery in the Americas, because the slaveholders had a labor source that was resistant to disease, and therefore were made more effective slaves than the indigenous people made, or that the indentured servants made. Culturally, this also entrenched the cultural differences between the North and South in the United States, because malaria was much more prevalent in the South, and the slaves provided a workforce that had resistance to that disease in those states. In the 1500s, the Spanish colonists in Peru found out from local medicinal treatments that the locals would treat fevers that were remittent fevers that would come and go, that is malaria, with the bark from this tree called the cinchona tree. And the first European to be treated with this bark was the Spanish viceroy's wife. So some monks brought this bark over to Europe, but it took a couple of centuries before Europeans took this as a serious treatment for malaria. And in 1820, 2 French chemists, Pelletier and Caventou, managed to extract 2 of the 4 active ingredients from the cinchona bark, that is quinine and cinchonine. And that gave the first diagnostic tool for malaria, and also the first medicinal treatment for malaria. And at that point, extraction of these chemicals from the cinchona bark became big business, became industrialized, and it's actually the origin of the modern pharmaceutical industry. In the 1870s, Louis Pasteur in France and Robert Koch in Germany developed the germ theory of disease, and were able to show the pathogens, primarily bacteria, that were responsible for a whole host of diseases that had plagued humanity throughout our history. And this led in the 1890s to Ronald Ross discovering that the vector of malaria was the Anopheles mosquito. He worked this out working in India, in British India. And you can see a picture of Ross here along with his lab notebook. It took him many years to sort this out in really grueling conditions. But for his discovery that Anopheles is the vector of malaria, he received one of the very first Nobel Prizes in physiology or medicine. And these are some of the drawings of Anopheles mosquitoes. Anopheles, by the way, is a Greek word that means good for nothing, but the mosquito was actually named before it was discovered that it's the vector of malaria. And so once this was discovered, then a ready solution was at hand. And Ross and other scientists pointed out that if we can just destroy the larva of the Anopheles mosquito shown here, then we could wipe out malaria. So this involved the cholicicides, which are pesticides for killing larval mosquitoes, available at that time, which were things like kerosene and chrysanthemum derivatives. So natural products and products found in nature that could be used to kill larval mosquitoes. This discovery also had profound impacts on history. For example, in colonial Africa, the scientists studying these infectious diseases discovered that African children were the reservoir for the malaria parasite that then infected the European colonists. So this gave rise to the segregation policies in colonial Africa, where the Europeans would separate themselves from the indigenous Africans, including to the extent of destroying the African homes that were near European homes in order to reduce the incidence of malaria. And this, combined with the use of quinine extracted from the cinchona bark, allowed the colonization of Africa. We can skip now to World War II, when the Japanese very quickly took over most of the island and coastal nations in Asia. And the United States, of course, got involved in this war on December 7th, 1941, with the invasion of Pearl Harbor. But very quickly, Japanese victories mounted as they took over nation after nation around the Pacific, including the mid-February to early March conquest of Java in 1942. And the most important reason for the conquest of Java is that 90% of the world's cinchona production was being grown on Java. So all of a sudden, the Western powers lost their supply of quinine from cinchona plantations. And the Japanese had plenty of stock of it. Malaria also led to the infamous Bataan Death March, because our troops were so sick with malaria that they were unable to fight off the Japanese forces. And this was the biggest loss of American lives since the American Civil War. We ended up having far more troops sick with malaria. Sometimes it was a 9-to-1 ratio as troops that were ready for the battlefield, as you can see here in a malaria clinic in Guadalcanal. So the situation was really quite bad. And we had far more troops as dying and sick from malaria and other tropical diseases than we did from combat. So there was a education campaign that was put into production, talking about the importance of using quinine, but this became impossible because the Japanese had taken over Java and the Nazis had conquered Amsterdam, where most of the stockpiles of quinine were being held. Dr. Seuss was recruited to do a propaganda campaign to get soldiers to take malaria seriously. And so there were a variety of different tools that were effective for that. And all kinds of ideas put in place to make the soldiers use their repellents and use mosquito nettings and so on. But the most effective thing that came about was the development of Atrobrine for our troops. And Atrobrine was actually a chemical developed by German scientists, but it's a synthetic version of quinine. So we started a campaign to get our soldiers to take Atrobrine. Many of them didn't like it. It caused what was called the Atrobrine Tan, which is a yellowing of the skin. Some people would get psychotic-like symptoms on it. And there was a rumor going around that it would make you impotent. So it was hard to get soldiers to take it, which is why an Australian commander started implementing all kinds of tools that spread around to the American commands too, like this one of advertising what happens if you don't take your Atrobrine. In 1939, a Swiss chemist, shown here, Paul Mueller, discovered that a chemical called DDT was a very effective contact poison for insects, including mosquitoes and other insects that vector deadly diseases such as malaria and yellow fever. The company that he worked for relayed this discovery both to the Nazis and to the Western powers. The Nazis were not very interested in DDT because they were more interested in their own development of hydrocyanic acid, but the Americans tested it, found it to be very effective, and started producing it in massive quantities for the war theater. Meanwhile, just before World War I, Nicole, shown here, discovered that typhus is vectored by lice. And typhus is the most common disease of warfare that kills people when they're crowded in trenches or in shelters or things like that. And so as the American and British forces pressed in upon Italy, when they conquered Naples in December 1943, they found that tens of thousands of Neapolitans had been sheltering in bomb shelters and caves under Naples, and there was a typhus epidemic. So the United States began a typhus eradication program using this new chemical, DDT, and they sprayed it on every single person in Naples between December 1943 and February 1944. And for the first time in history, stopped a typhus epidemic in its tracks. To put this in perspective, typhus has a mortality rate that makes COVID look like child's play. For example, in the Crimean War, at times 70% of the people infected with typhus died from it. So these are pictures of the Allied invasion at Anzio in Italy. The Nazis, as they retreated, had blown up the dams that this was formerly reclaimed farmland. They flooded these in order to make malaria rampant again in order to infect the invading troops. And the United States responded by spraying massive amounts of DDT in order to prevent a malaria epidemic. We then started spraying as we marched through Europe and reconquered this territory. We started spraying our soldiers, we sprayed refugees. The bottom picture shows a child at the end of the war being sprayed with DDT as children were being evacuated from Berlin to prevent starvation. And we sprayed our barracks, we sprayed Holocaust survivors, refugees, soldiers, everyone was sprayed with DDT in order to prevent typhus. The very first civilian use of DDT occurred at Jones Beach in New York in August 1944, when this truck rolled down the beach and sprayed it to kill all the biting flies on the beach. And in this operation, this model was hired to sip a Coke and eat a hot dog in the cloud of DDT in order to show everyone how safe it was. And very soon it became available to everybody. So you can see here an advertisement for Gimbals selling this DDT bomb in the fall of 1944. And Dr. Seuss worked for this company, Flit, which started integrating DDT into its famous Flit gun spray. Here's another ad that Dr. Seuss made. And we started spraying DDT absolutely everywhere to kill flies and mosquitoes and other insects in our homes and our cities. We had advertising campaigns about how it's good for you, increases production on farms and meat and so on. If you took a flight, the flight attendant would spray DDT in the airplane. You could get DDT impregnated nursery wallpaper to keep your baby safe from flies and mosquitoes. And then in 1962, Rachel Carson published her famous book, Silent Spring, which alerted the world to the dangers of this rampant use of chemicals such as DDT and how it was causing the extinction of wildlife and endangering human health. Part of this was that the average American was accumulating DDT in their fat tissues at unacceptable levels in the up to 12 to 15 parts per million. And also it was discovered that women had DDT in their breast milk at levels that were 3 to 4 times higher than what was allowed in grocery store bought milk from dairy cattle. There was a Berkeley group that made this advertisement to alert people to this danger. So finally, I'll just mention a few other pandemics that had a major impact on human history, starting with Black Death. So at the upper left, you can see the famous Dance of the Dead from the bubonic plague epidemic that wiped out between 1/4 and half of the European population. And this may have been an artist's rendition of what's called St. Vitus dance, which is a neurological disease associated with bubonic plague. People blamed the Jews in many parts of Europe and destroyed the Jewish population in giant fires, which is what you see on the upper right. At the lower left, you can see the flagellants, which thought that God had brought bubonic plague upon the Europeans as punishment for their sins. And so they would march through Europe, self-flagellating to try to appease God. And at the lower right, you can see a plague doctor And the plague doctors, ironically, would be spreading plague as they went from house to house because they would carry they would carry the fleas with them that vector plague from person to person. Yellow fever is another great example. In 1793, there was a yellow fever outbreak in Philadelphia, which at the time was the capital of Pennsylvania, but also the capital of the United States. And that outbreak killed 10% of the population. It led to the founding fathers fleeing the city, and it led to a constitutional crisis because at that time it was unconstitutional to hold government sessions outside of the city, but nobody would go into the city to hold sessions. So it was a disease that wiped out huge numbers of people in the United States from the first colonial days all the way through to the late 1800s, but it also led to the collapse of our government in 1793. In the Spanish-American War, the United States conquered Cuba, and after we conquered Cuba, so many of our soldiers were dying from yellow fever in Cuba that the United States set up the Yellow Fever Commission led by now I'm having one of these brain freezes, Walter Reed. And they did an investigation in Cuba where they set up this is Walter Reed's hand drawing of their experimental setup. They had one room where volunteers would be protected from mosquitoes. It was completely surrounded by mosquito netting, but they would sleep and live in the midst of unbelievable filth of the feces and vomit and blood of yellow fever victims. They'd have to sleep in that. And in the other room, people were in absolute sterile conditions, but not protected from mosquitoes. And the people who were not protected from mosquitoes got yellow fever. The people who were living and sleeping in the excrement and vomit of yellow fever victims did not get yellow fever. So they proved that yellow fever is vectored by a mosquito, in this case, a mosquito called Aedes aegypti, and it's not transmitted from soiled or filthy clothing, as had always been thought. This discovery led to the eradication efforts of malaria and yellow fever, first in Cuba and then elsewhere around the world through the draining of any small standing bodies of water and the treatment with pesticides of larger bodies of water. It also allowed the United States to complete the construction of the Panama Canal. The French had failed because they lost so many of their workers to yellow fever and malaria. But because of the draining of wetlands and the use of pesticides, the United States succeeded. And in order to do this, they also carved off Panama from Colombia. It was part of the country of Colombia, and we supported so-called rebels in order to separate it so that we could control the canal zone. And finally, I'll just mention typhus, as I talked about before. It's the largest killer during times of war. And I just brought up one example of this. This is the famous figure showing Napoleon's march to Moscow in the War of 1812, where he started out with about 500,000 French troops. And by the time they marched to Moscow and then marched back to France, they ended up with about 5,000. And if you read this classic figure and look at the classic literature, it says that the French soldiers died from the cold. In fact, they died from typhus. It's just that their freezing, crowded conditions led them to be in conditions where there were lots of body lice, which transmitted typhus and wiped out almost the entire force. So with that, I'd love to turn it over to any questions and discussion, and I will stop my screen share for that.
Thank you so much. Gosh, that's pretty amazing stuff. So it usually takes a couple seconds because we are on a little bit of a delay to get questions in, but it looks like we already have one. Lisa from Flagstaff asks, says, your examples show that during pandemics, people are eager to jump on a cure. What lessons can we learn from human history as we rush to find and disseminate a cure for COVID-19?
Yeah, it's a great question. So there's never been a cure developed as fast as the aggressive timeline that we're under now for COVID-19. And part of that was that the science would not have facilitated such a rapid development in the past because we did not have the tools we have now, including these incredible genomics and proteomics kinds of tools where you can screen thousands of chemicals for effects. So I would say that there are some lessons from past pandemics. One of them is that one of the fears that I had when this outbreak occurred is that we may get the breakdown of society, like has happened in many other past pandemics, like with bubonic plague, where society completely broke down. That hasn't happened, fortunately. We've had some unrest, of course. We've had various small-scale difficulties around, but we haven't had the collapse of society. So that's the positive side. The negative side, I think, is that we're seeing this federal government politicizing the development of treatments, vaccines for COVID in order to look good before the election that we're about to have. And of course, that's quite dangerous. We have to have our public health agencies be completely non-political and follow the science and not be pushed or rushed into something that may not be ready. So I am worried, like many people are, that we'll have the Trump administration try to push forward something before it's ready to be, in order to have something before the election. And I'm quite confident we won't have an effective vaccine that's been tested until well after the election. So I'm not sure if I fully answered your question, but I'd be happy to follow up if there's something else.
We'll see if she go ahead. Lisa, if you have a follow-up, please go ahead and submit that. Right now, I do have Susan from Flagstaff who asks, what is the next probable big disease?
Yeah, so that's a great question. And actually, if you go back to some really nice literature on infectious diseases that was produced in the 1980s and 1990s, what we're going through now was predicted, not exactly which pathogen it would be, but that we would experience another pandemic. And the reason is that humanity has been pushing its way into a habitat we've never been in before, pushing into the rainforests of Africa, pushing into the rainforests of Asia, and so on. And not just going into this habitat we've never been in before, but also then eating animals in that habitat, eating bushmeat. So, for example, we've had a number of epidemics arise from Africans eating bushmeat, like HIV going from probably chimpanzees into humans from eating of chimpanzees. But we also have our current COVID pandemic that occurred because people were eating bats, which carried COVID-19, or possibly pangolins that had been infected by bats that had this in a wildlife market. So this current pandemic we're going through is a bat coronavirus, and it came from consumption of bushmeat, these bats being brought into the wildlife bushmeat trade. And so we can anticipate that we will experience many more of these epidemics and pandemics as long as we are pushing into these habitats and eating these animals that we shouldn't be eating. One of the things that is a positive outcome, I think, of going through the current pandemic is we will have much better tools following this for rapid diagnosis and treatment than we had before this.
Thank you. David Ross from Flagstaff, I think you almost answered this, but he says the president was quoted on saying he'll have a vaccine for the coronavirus in a few weeks. What are the chances that that will actually happen?
So there's zero chance that we'll have an effective vaccine that's safe and ready for use before the election. I think that the most aggressive table, based on the number of vaccines that are currently in stage 3 clinical trials, is that there would be a vaccine ready for first-line responders, medical workers, in January, right around there, and probably then a phase-in over the next 6 months to broader use as more testing is undertaken. But we have to keep in mind also that the testing in these trials is on adults, and we don't yet have testing occurring with children. And so it'll take longer before we have a vaccine ready for children than it will for the rest of us. So my guess is that the first people who will get the vaccine once it's shown to be safe will be the medical workers. Probably after that, it'll be the most vulnerable people in society, like the elderly and people with compromised immune systems. And then it will be other adults. And then once it's been shown to be safe for kids, going into the kids. So we're probably looking at another year before everybody can be treated with a vaccine.
Thank you. Anna from Winslow kind of shifts gears a little bit. She says, pest-borne diseases seem to be easily controllable through hygiene. What are other vectors to know about?
Yeah, so unfortunately, they're not easy to control. So the malaria example that I gave you, if I can return to that example, DDT was super effective against Anopheles and thereby was able to wipe out malaria around the world. But because we didn't restrict use to public health, we then used it everywhere. We used it in our homes, in our wallpaper, in our agriculture, in our forestry. Within a couple of years, the Anopheles evolved resistance to DDT. And this is what we've seen with chemical after chemical. If we could only preserve them for public health, they would be amazing tools, but we never do that. We always then use them everywhere, and they then lose their utility very quickly. So malaria is once again the #1 killer as far as infectious diseases go for humanity. And it's because of our hubris of just broadcasting these chemicals all over the world. So unfortunately, they're very difficult to control, not easy at all. And there are many of these infectious diseases that are vectored by animals, primarily by arthropods.
Now, malaria is controllable now, though, isn't it?
Not really. So
No.
there's 4 main varieties of malaria, and one of them is quite deadly, and a lot of people still die from that. One of them is much more benign. So it depends which variety of malaria that you contract. But even the prophylactics that you can take for malaria, the protist, that's the malaria parasite, evolves resistance to those very quickly. And we have to shift which prophylactic we use every 6 to 10 years because of that. So malaria is nowhere near under control. We have eradicated it from the United States, and it's been eradicated from Europe, but it's endemic in the rest of the world.
Interesting. I recall when I was younger and traveled, I had to get malaria shots, and then I wasn't allowed to give blood, I believe, for a good 5 to 7 years after that.
Well, you wouldn't have gotten malaria shots. There's no vaccine for malaria. You would have taken a malaria
Pills.
pill for a
Mm-hmm.
prophylactic. Yeah.
Yeah. Okay, we have another question. JP from Flagstaff says, what assurances will we have or might we expect that these rapidly developed vaccines are safe? DDT was advertised as healthy, and it clearly was not.
Yeah, so that's a great question. So first, make sure that I answer your question, but I want to just back up a little bit. It was actually a safe application of DDT to spray people down to kill the body louse to prevent typhus. And people did not get sick from that. People got sick from long-term exposure to DDT through their food. And that's the way that it wasn't safe. And that's also how it killed wildlife, was long-term chronic exposure. But in terms of your question of how do we know a vaccine is safe, how can we trust the federal agencies responsible for developing these vaccines that it's safe? And I too have skepticism based on our current government that we can trust the government that this will be safe. However, we have some other means to know that it's safe. That is that these vaccines are not only being developed in the United States, they're being developed in Europe, India, China, many other countries, Brazil, are developing these vaccines. And they're also being tested. The ones that are being tested in the United States are also being tested in these other countries. So we will have a data set that doesn't rely on filtration by the United States government to know if they're safe. Also, the major vaccine companies that are developing the COVID vaccine have signed a pledge that they will not be influenced by the politics in their decision-making about when the vaccine is safe. So I think that we can trust that these companies and the international organizations like the WHO and the European vaccine agencies will tell us when they are safe to use. We have excellent scientists at the FDA and NIH and other federal agencies in the United States. The problem we have in the United States is the political leadership of those agencies has been corrupting the process. But the scientists there are totally trustworthy. So I understand the question and skepticism, but thankfully we have the assurances also of this international testing and the pledge by the major pharmaceutical companies to not let the process be rushed or politicized.
Thank you. We have another question. Alex from Flagstaff says, if we continue to see an increase of pandemic disease, especially if the human race continues to propagate and migrate throughout the globe, what precautions can we take as a species to prepare for and prevent future outbreaks?
Yeah, it's a great question. So we have the Federal Emergency Management Agency that's ready for the next hurricane. And we have seismic monitoring stations that are ready to detect the next earthquake or tsunami. So why did we have the weakening of our infectious disease preventive agencies when the Trump administration came into office? You know, this is a major problem. We need to have an incredibly strong infectious disease federal agency, presumably led at the CDC, that's constantly equipping itself for the next pandemic and doing the first testing, going to those hotspots when they arrive, isolating the disease where it occurred. If you think back to the Obama administration, they were able to stop an Ebola outbreak in Africa and prevent it spreading around the world. And Ebola has something like an 80% mortality rate. So it's much, much worse than COVID. That's what we need. This we need this insurance in place. And if we don't have another pandemic for 100 years, it will have been well worth that money, whatever it costs to be prepared for it, even if it doesn't happen.
Thank you. Angela from Flagstaff asks, did the US government support the dissemination of DDT to American citizens?
Yes, in fact, after World War II, the United States allowed chemical companies to use former chemical weapons plants to produce pesticides in vast quantities, including DDT. And so the production of these chemicals, DDT and other wartime pesticides, was subsidized by the U.S. government.
Okay. And on a lighter note, Hector from Flagstaff asks, what's that thing hanging on the wall behind you?
That's funny. So I'm in my messy office at NAU, and yeah, in the background you can see there's a piece of baleen. So the mysticete whales, which are the giant whales, don't have teeth. They have these keratinous plates called baleen in their mouth on both the upper and the lower jaws. And that piece of baleen is from a bowhead whale in the Arctic. I'm from Alaska, and I do a lot of work with Alaska Native communities, and I have a lot of Native Americans who work in my lab. In Alaska, there are Alaska Natives who worked in my lab. And there's a group in Alaska called the Alaska Native Science and Engineering Program that sponsors the scientists to have Alaska Natives work in their lab and become scientists. So after working with this group for many years, they gave me this award in a very nice ceremony of the baleen to thank me for mentoring Alaska Native students in the lab.
Very nice.
Yeah.
Thanks for the question, Hector.
And my office is full of all kinds of strange things.
So what, all of the examples you gave led to really huge and some unforeseen impacts on society. And I'm guessing that you go into that a little more in your book. What do you see? You said you're not seeing the breakdown of society right now, but can you see any trends starting that you think COVID will have a lasting impact on us that maybe we wouldn't have thought of to the beginning? Like, I'm wondering if we're still going to keep wearing masks for a while.
No, that's a terrific question. And I'm sure it will have lasting impacts on our behavior. And I don't know what those will be. One of them might be that we're much more happy and ready to wear masks than we were when this started. And that might help the next pandemic, that we're much more responsive than we were this time around. But I would think that there'd be many other facts. So one example would be when this started, we were all groaning that we couldn't go to the office and we had to work from our homes. And many people like it. And so in Flagstaff, it's awesome to walk to work. I do it every day. But if you live in Los Angeles or New York City and you don't have to spend 3 hours commuting and you can work from home, that's pretty terrific. So for those people who have the privilege that they can work from their computer, I think a lot of people have realized this is a better way to work. And maybe we will no longer need big office buildings in cities anymore because everyone can work from their home in those kind of office environments. So I do think there will be some big shifts in our society based on this epidemic. I don't know exactly what they'll be.
Okay. And I was also wondering, the main pandemics that you looked at were spread by insects of some sort. It's fleas or mosquitoes or something that we can't truly control. I mean, we could douse them with DDT and be done with it that way. But COVID is spread by us, by, us. Is there another disease out there or another pandemic that you can kind of relate COVID back to that might be something to examine?
Yeah, so I think one way to look at this that's really quite interesting is the lethality of a disease. So COVID is not very lethal, right? The percent of people who die from it is probably a little bit under 1%, which is horrible, but it's not 70% like typhus
Right.
at the height of a typhus epidemic. It's not 50% like the bubonic plague. And so its mortality rate is relatively low compared to these massive pandemics that have affected humans in our past. And so one of the disadvantages of a pandemic that has a low mortality rate is it's a lot harder to stop. Like COVID, probably about half of the people who get COVID are asymptomatic. And so if you're asymptomatic, you don't know you're sick, you're going to be spreading it around without knowing it. That's what's happened with COVID. Whereas you look at SARS, SARS had a much higher mortality rate. And the CDC and the WHO and the Chinese equivalent of the CDC, they were able to stop it very quickly and prevent it from becoming a pandemic. Why? Because so many people were dying, people who got it were dying so quickly and at such a high percentage that you could find the hotspot, isolate those people and stop it. So one of the things that happens when you have a pandemic that has a low mortality rate is it's a lot easier for it to go global than if you have a high mortality rate. So it's good because the mortality rate's lower. It's bad because it can spread a lot easier.
Interesting. Well, I don't see any more questions. So do you have any other comments, anything you'd like to leave us with?
Well, so maybe one more thing I'll talk about is famine, because oftentimes pandemics are associated with famine, both as the cause and the effect. And that was another thing that I was worried about with COVID. We did see people going hungry in India when India went into its lockdown because the people who could afford it hoarded the food. And so many people went hungry in India. But in most of the world, we're not seeing any broad scale famine yet from COVID. And that was a big worry of mine. If we go back and look at the Irish potato famine, which was in the 1840s, that famine killed over 1 million Irish, and it led to over 1 million Irish fleeing from Ireland and colonizing the Americas and Australia and other parts of the world. It completely changed the makeup of our country. And what happened there is that the British had put into place these very fierce laws that drove the Irish to be able to support themselves only on the most marginal of lands. And the only crop that they could grow there was the potato. So we had over 90% of the population of Ireland living pretty much exclusively on the potato on a monoculture. And then when the potato blight, which was a water mold pathogen, found its way over from the Americas to Europe, it wiped out the potato crop and caused this massive famine. And when people are going hungry, they typically don't actually die from starvation. They die from infectious disease because their immune system is compromised as they have a lack of nutrition. And that's exactly what happened in Ireland. So the Irish actually primarily died from typhus and relapsing fever, both of which are vectored by the body louse. So these were people who didn't have enough nutrition. They were crowded, living in very filthy, dirty conditions with a lot of lice, and they died from typhus and relapsing fever. And so we can see it both ways. You can have a famine that leads to a pandemic, and you can have a pandemic that leads to famine.
Wow. We did get another question. Morgan asks, can you explain herd immunity?
Yes, that's a great question. So earlier, somebody was asking about development of a vaccine. And what I should have said is that once we have a safe vaccine, it's critically important that all of us take it. And the reason is that you have to have a large percentage of the population be immune to the disease before the spread will slow down and stop. In the case of COVID, scientists are trying to sort out what percent of the population has to be immune before the disease will stop spreading. It's probably somewhere around 70 to 80% of the population. And there's two ways to get to that level of immunity. One way is people get COVID. Once they get it, they'll probably have immunity for 6 to 18 months based on the behavior of other coronaviruses. But that's not a very good way. We don't want the world all getting COVID and 1% of our population dying. So the much better way to achieve herd immunity is have at least 70 to 80% of us getting the vaccination once we have a safe vaccination. And that's not only preventing ourselves from getting sick, it's preventing other people from getting the disease. So this is where the anti-vaxxers pose a very serious threat to public health, because if enough people don't get the vaccine because they're worried about health effects from the vaccine, it can cause this pandemic to not get under control. And unfortunately, this anti-vaccine movement that's about autism caused by vaccine is a false move. It's based on false data. Vaccines do not cause autism. Vaccines can cause health problems. And if you look at the warning sheet for any of the vaccines that we all have taken during our development, they'll have things like 1 in a million people can get this reaction, but they don't cause autism. That's a false thing that was spread around in a very unfortunate way. Yeah. So what we need is, once we have a safe vaccine that's proven to be safe, we need as many of us as possible to take it. So we have herd immunity, at least probably 80% of us taking that vaccine.
I know I'll be in line for that one immediately.
Yeah.
Anne from Flagstaff asks, do you think COVID-19 will reverse globalization trends?
I don't think so. It's a great question, because the reason why we're having pandemics is because we have globalization. It was the same thing. The reason why we got the Irish potato famine was because of globalization. It was global trade. We had steamships developed in the 1830s that allowed rapid transport of products from the New World to the Old World, and they were bringing over seed stock of potatoes that carried the pathogen with it, and keeping those frozen on ice in the ships, and that allowed the pathogen to infect the European potato fields. In the same way, it's the fact that people from Wuhan could fly all over the world that spread COVID-19 around the world very quickly. In the same way, in the Obama administration, when we had the beginning of an Ebola epidemic, why? It was because people could go to those places and fly out and infect people in other parts of the world. So we had people with Ebola in the United States who would come from Africa. So yes, the globalization, it's here to stay. I don't think there's any way to stop it. But we have to have better protective measures in terms of infectious diseases. Someone asked a great question before about what else can we do. And one of the things I should have said is that scientists are now establishing these very important genomic and proteomic kinds of databases that will allow us to detect future viruses much more quickly. And so we have to have suitable funding for that, and we have to have a very strong, non-politicized CDC to lead that.
Thank you. Oh, here we go. Colby asks, how long do we have to wait to determine a vaccine is safe?
Right. So the way that the vaccine trials work is they go through three stages of trials. The stage 3 trials are where you get tens of thousands of people tested for the safety of the vaccine, looking for any adverse reactions. And in stage 3 trials, if you have a single person get an adverse reaction, they actually halt the trial, figure out what caused it before they'll resume the trial, which just happened a few weeks ago with one of the vaccines. But right now we have something like 8 or 9 vaccines for COVID-19 that are in stage 3 trials that are being tested on tens of thousands of people. And once those tests are complete, which should be probably around December, we'll know whether those vaccines are safe in terms of that length of exposure, which is several months afterwards. The problem is we won't know if there's any long-term effects on health for a couple of years. But we can't wait a couple of years before taking the vaccine. And COVID is dangerous enough that if there are long-term health effects, they're probably sufficiently rare that it wouldn't prevent most of us from getting the vaccine. So again, my guess is come January, February, we'll see frontline health workers getting the vaccine. And we'll have more data over time on if anyone's having adverse reactions. But this question about whether there's reactions years later, unfortunately, we'll have to have the vaccine before we know if there's a small number of people who have adverse reactions years down the line.
All right. Well, thank you very much for your presentation here. We at the Flagstaff Festival of Science certainly appreciate you contributing, and this has been pretty fascinating, and I am going to plug your book again to the folks. It's called The Chemical Age: How Chemists fought famine and disease, killed millions, and changed our relationship with the earth. And you've got a whole section on pandemics, along with some other other areas that you examine about how chemistry has affected humanity. And that is published by the University of Chicago Press. So everybody run out and get a copy.
Thanks so much, Sherry. I really appreciate it. And I always love the opportunity to talk to this festival.
Well, thank you very much. We appreciate it. Whoops, hang on. Looks like we got somebody in under the wire. His name's Andrew from Flagstaff, and he asks, how long can COVID stay in the air?
Yeah, that's a great question. So people are working on both how long can it last in the environment and how far can it travel, like if someone sneezes, which goes into those social distancing rules that we've been following. And so initially, if you remember back to when we first learned about this pandemic in January, February, March, people were really concerned about getting sick from touching a park bench or a railing that someone had touched who had been sick. And it turns out that the virus does not last very long in that kind of situation. And people basically aren't getting sick from contact in that way with COVID-19, maybe occasional, but it's not a major pathway. And it turns out what you're asking is the major pathway. That is the respirable virus coming in when someone sneezes or coughs or sings or produces it that way. And how far can it travel in the air depends on a lot of things. It depends on if there's a little bit of a breeze, for example. It depends on whether it's a sneeze versus talking. So for example, if someone sneezes, the virus could probably go something like 30 to 40 feet from where the person sneezes. Whereas if someone's just talking, it appears that being at the 6-foot distance is safe. So the main thing though is wearing the mask. Initially, there was a lot of confusion around the mask back in January, February, March. We now know that we can both prevent ourselves if we have it from having it transport through the mask, and we can prevent getting it by wearing the mask. So it looks like the combination of wearing the mask and maintaining the social distancing and being in small groups is quite effective. You can see this, for example, in Arizona. If you remember back to late May and June, we had this huge spike in cases in Arizona. And at that time, very few people were wearing masks and we weren't social distancing very well. Then we had a big shift in our behavior and our infection rate went way down and we're no longer one of the top states. So to answer your question, if there's no mask and you have a sneeze, it could probably go something like 30 to 40 feet. But wearing a mask and you basically are not allowing the virus to escape from your person.
We've gotten more questions, so that's
Sure.
good. Emma from Flagstaff asks, well, isn't it risky to test vaccines on healthcare workers?
So they're not testing the vaccine on healthcare workers exactly. What's happening is that we have volunteers who are participating in the stage 3 trials, again, tens of thousands of people for each of the vaccines in development. And the vaccines that are in development are not put into human trials until they've been tested on laboratory animals. So first you go through laboratory animal testing to make sure that they don't cause health effects in animals. And these are animal models that have been used for vaccines for over 100 years. And once they're shown safe in animals, then we go through the small stage 1, medium stage 2, and then the large stage 3 trials. So sure, there may be healthcare workers that volunteer, but only volunteers are in those trials. And these are people who are willing to take the risk. And the risk is really quite small. If you look back at vaccine development for other coronaviruses, for example, the flu vaccine that's developed every year, the risks of these are generally quite small. So I don't think it's a big risk. I wouldn't mind being a volunteer myself for a trial. And I think that the vaccines will be, once we have it done, they'll be safe. The question is how effective they are as well. We haven't talked about that. You can have a vaccine, and maybe the very vaccine is only 70% effective. It's still then worthwhile doing, but that's not as good as if it's 99% effective.
Right.
So it's both how safe it is and how effective it is. And we won't know that until we're done with stage 3 trials.
Yeah, and I think these trials are going to be much better than Walter Reed's malaria trials.
For sure. And in fact, one of the interesting things about the Walter Reed trials in Cuba is that was the very first time that an informed consent process was used in medical research. Before that, people were tested without their knowledge. And that, even though it was a very primitive informed consent, they actually asked for volunteers and they had them sign a form. it was the first time that was ever done.
Interesting. All right. All right, let's look and see if we've got any more questions. All right, no one sneaking in at this point. We've got 5 more minutes if you have anything else.
Well, maybe I'll just mention that we talked about infectious diseases. We talked about famine, and another thing that quite interests me about this whole field is that a lot of the pesticides that were developed to combat these vectors of disease, to kill the mosquito, to kill the body louse, to kill the flea, these were chemicals that were actually developed by the same scientists who were developing chemical weapons. So this incredible intellect that was being used in this to develop public health tools, they were also developing chemical weapons to kill people, because the chemistry can be manipulated just a little bit between killing people versus killing insects. So I think that's a really interesting part of this whole history.
And they all ended up having big impacts on our environment too. So
they did.
Huge. Well, once again, thank you very much.
Yeah, thank you, Sherry. I appreciate it.
Thank you. And I hope folks join us again tomorrow at 3 p.m. for the festival's final presentation, Yellowstone's Newest Thermal Area with Greg Vaughn. Thank you very much, everyone. Have a lovely evening and enjoy the rest of your weekend.
Take care.
Bye.